To solve inequalities with an absolute value in them, first I get the absolute value part by itself, and then I transform the problem into a compound inequality. Compound inequality meaning two inequalities, or two or more inequalities. In this case, I do one equality where it looks just the same but without the absolute value sign, and then I do another where the absolute value sign kind of acts like a giant negative. And in between those two, I either put the word or I put the word and, once I get this the right color. For greater than situations, because the word greater sounds kind of like the word greater, I'm going to use or. The solution to this inequality will be the solution to this compound inequality. I'm going to solve each of these inequalities on their own. And then the word or means that I'm going to keep the solutions from both of these inequalities. If it were and, I would look for an overlap, but or means I'll keep the solutions that are greater than or equal to 7, and I'll keep the solutions that are less than or equal to 5. The x values that meet this absolute value inequality are x values that are within the set negative infinity to 5, including 5, union with 7 to infinity. To solve absolute value inequalities, first I get the absolute value part by itself, and then I split it up into a compound inequality, one where the absolute value sign just kind of disappears, and the other where it's like the absolute value sign acts like a giant negative. And in between, I'll put the word or I'll put the word and. For greater than, I use the word, oh, this was not greater than. For less than, I use the word and. Greater has or in it, so this is the one that's not or, it's and. Less than, I use and. I solve each of these individually. And then the word and means I'm looking for the overlap between these two. I'm looking for numbers that are at the same time less than 4 as well as greater than negative 6. The overlap between these, the numbers that got colored in by both of them, that got colored in green and purple, are the numbers between negative 6 and 4, not including negative 6 or 4. Right? Negative 6 got colored in purple but not green. 4 got colored in green but not purple. There was an open purple circle, so that means it's not actually purple. So my solutions are the numbers between negative 6 and 4, not including either. To solve absolute value inequalities, I get the absolute value part by itself, and then I split it into compound inequalities. One where the absolute value sign just kind of disappears, and the other where the absolute value sign acts like a giant negative. Because this was a greater or situation, I'll put the word or, and I'll solve each of these. My solution are going to be the two sets of numbers, one set of numbers that are greater than 1, the other set of numbers of the numbers that are less than negative 2. Because it was an or situation, I take both. Both of these are part of my answer. I don't need to look for an overlap like I would with and. My solution are the numbers from negative infinity to negative 2, union 1 to infinity. To solve absolute value inequalities, I get the absolute value part by itself. And then I split into compound inequalities based off of one of them being what I get if I just ignore the absolute value signs, and the other being what I get if I pretend like absolute value has the effect of making it negative. Now, I happen to know that this problem is going to come out to no solution, because absolute value of something is never going to be less than a negative number. At worst, absolute value will be 0. Usually it's positive. Almost always absolute value makes something positive. At lowest, it's 0. Never is it going to be smaller than a negative. But if I just don't notice that, and I just follow the math, I split into my compound inequalities. In this case, I'm going to have the word and in there because it's less than as opposed to great or. I get x is less than or equal to negative 6 and x is greater than or equal to negative 2. So because it's and, I have to look for the overlap. I look for where there's an overlap between being less than or equal to negative 6 overlapped with greater than or equal to negative 2. There is no overlap. So my solution is the empty set. The empty set. No solution, however you want to write it. Right, this number line looks like I colored in numbers, but that was just my work. The number line that really represents my answer is the number line with the overlap between green and blue, the number line of numbers that got colored in with both colors, and there's no color that got colored in with both.